So for the second part of our discussion about scientific notation, I want us to look at what happens when we are going to be doing a calculation involving scientific notation and sig figs. Now, most of the calculations in chemistry actually deal with division and multiplication, and the sig fig rules for division and multiplication are a little bit different than those for addition and subtraction. So we're going to save addition and subtraction for later. Let's just look at multiplication and division today. Now, you will need your scientific calculators, and I'm going to tell you how to put these values into your scientific calculators. Somewhere on your calculator, there's going to be a value that stands for scientific notation. If you have a graphing calculator, it is the EE button. If you have a another type of scientific calculator, it might say EXP. And by the way, on the graphing calculator, that EE button is the second comma function. So you'll need to look for that. Some calculators say times 10 to the n. And if it's not one of these, you're going to have to get with me and let me help you figure out what your E button is. So the E button is going to equal one of these two. When I say E, I mean whatever button on your calculator refers to scientific notation. Keep in mind that whenever you push that button, it stands for times 10. If you ever put times 10 into your calculator, actually plug in the times button and the 10 number values, you are going to probably miss the problem. So you never plug in times 10, you just use the E button, whatever that might be for you. So if I were going to put this value into the calculator, for instance, I would put in 4.245. I'm going to find that E button, and whatever that E button is, that's what I'm going to plug in next. And remember, the E button stands for times 10. Okay, so don't put in times 10. Just push whatever your exponent button is. So E4, and then you're going to put in and push the division button, divided by 2.9. Find your E button again, push that, your exponent button, do not push times 10, and then make sure you're pushing the negative sign, not the minus or subtraction button, but the negative sign, or -3. That's how you're going to put that value in. When you get that answer, again, when you plug this into your calculator, you're going to get, sometimes it'll plug out a nice, perfect scientific notation answer for you, but sometimes it's going to actually just give you a regular notation value. In this case, it comes out, if you did it correctly, you should have come out with this. Now, that is not the way you can report an answer. I know in math, when you get an answer, they pretty much teach you just to write the whole answer down. But in science, we cannot do that. In science, we cannot have an answer that has more sig figs than the values we use to calculate it with. So the first thing you're going to have to do anytime you have a calculation is to count up the sig figs in your values that you calculated with. The 4.245, easy, 4 sig figs. All of those are significant. The 2.9, 2 sig figs. The powers of 10 don't count. So the rule is that the number of sig figs in the final answer, as it says up here, must be the same as the lowest number of sig figs in the given value. So between 4 and 2, the lowest number of sig figs is 2, so my answer has got to have 2. So how am I going to do that? Well, I always tell everybody to do scientific notation first and then sig figs, because once you get it in scientific notation, every digit is significant, and that makes it really easy to come up with your correctly rounded answer. So let's get at this in scientific notation first. We just learned that if we have the decimal showing, we just simply need to show where the decimal needs to be moved to, and it needs to be moved so that there's only one non-zero digit to the left, so we move it between the 1 and the 4. Since it is a number bigger than 1, we know it's going to be times 10 to the positive something. Let's look at how many digits we need to, how many places we need to move it. 1, 2, 3, 4, 5, 6, 7 places. Number bigger than 1 means that's a positive 7. So we end up with 1.463793103 times 10 to the 7th. Again, that is not the correct number of sig figs. We need 2 sig figs. So let's draw our 2 sig fig line. Every digit is significant in scientific notation, makes it easy. We're going to draw it here. Our target number we're going to look at, the value right after the sig fig line, is the 6. That 6 is 5 or greater. It's bigger than 4, so we're going to need to round up. And since it's scientific notation, the beauty part is we always just drop everything else. So the answer here that we report is going to be 1.5, drop everything else, times 10 to the 7th. Now, I know for pure math people it drives them nuts, but remember, we can't give, in science it's huge, we cannot give a super exact number for an answer if the values we use to calculate with were these not nearly as exact numbers. So 1.5 times 10 to the 7th is the correctly reported value. Okay, let's do one more. Let's look at the next example. Now, one other thing I want to tell you, for some reason, sometimes if you have this button on your calculator, it's going to mess up if you don't put the second number in parentheses. So if you keep getting the wrong answer, your calculator, the way it works, and all calculators are different, the way it works, if you have that button, sometimes it's that you have to put this value right here in parentheses. So watch for that. We're going to be working on this a lot in class, so that'll give you a chance to practice it. Okay, our next example then says that we are going to be putting in this calculation in our calculator. So let's follow along while we do that. We know that we're going to be putting in 2.200. The times 10, remember, is taken up by whatever your exponent number or button is, 3. And then you're going to push the multiplication button. And then 7.10, don't push times 10. That is the most common mistake. You push times 10 and you're going to mess up. So 7.10, whatever your E button is, and then your negative symbol, not subtraction, but negative, and then 7. And then hit your enter. When you do that, you're going to end up with a value of 0.001562. And let's think about what we have to do to get the correctly reported value now. The first thing we need to do is to make sure that we've counted up our sig figs in our given values, in the values we use to calculate it with. So keeping in mind that all sig figs, all digits are significant for scientific notation. That means all of these are significant, so we've got 4. And all of these are significant, so we've got 3. What's our rule? Our rule is we go with the least number of sig figs, so that means we're going to go with 3 sig figs for our final answer. It's always easiest to get it in scientific notation first, so let's do that. We know we need to move the decimal to here. This is a number less than 1. What does that tell us? It tells us that we're going to have a negative exponent. So this is going to be something times 10 to the negative exponent value. So let's see what that negative value is going to be. First of all, we know that we're going to have 1.562, and to get that decimal moved, we need to move it 1, 2, 3 places. So times 10 to the negative 3 for our answer. And finally, the last thing we need to do is to change that value to the correct number of sig figs. We just said up here that we wanted it to be 3 sig figs, so let's draw our sig fig line. The sig fig line after our 3 sig figs says we're going to draw it after the 6. And our number that we look at, the very next number, is a 2. So do we round up? No, we do not. We just drop it. So our final answer becomes 1.56 times 10 to the negative third. That's our final answer.